Hello everyone. So today we are going to study about anti-reflective coatings. So what are anti-reflective coatings? We are going to study over here, and what is the principle, on which principle does this coatings work, and what are the uses and also the benefits of these coatings, right? So these coatings are also known as anti-reflective or anti-glare coatings, and they can be defined as any optical coating which are applied onto the surface of the optical medias or optical materials. That can be either any glass lens or any spectacles or any window glass or any screen, right? Which will help to reduce the amount of reflection that occurs at interface between the material and the air or any other material. So as you know that it's a property of light to either reflect or either diffract, right? So I have already discussed in catoptric images that as any there is a difference between any media. Light can either reflect or diffract. So when I have told in the catoptric images that how catoptric images are formed, they are formed by the reflection of the light rays from the ocular medias, which were cornea and the lens. So similarly, any glass material or any optical material or media, or if there is any change in the medium, right, which we call an interface, comes, and for example, when a light ray is coming from the air to and striking onto the surface of any glass screen or any lens, the light, what happens over here, the phenomena of refraction is occurring. By that refraction, it does not mean that only all over the light will refract, right? So it doesn't mean that light coming from here and it's striking in this type of optical media is refracting like that. There is some amount of light that reflects back. So the catoptric images were the same thing, and were useful because that were concerned to the ocular medias, right? But when we are talking generally, that reflection of light from any of the lens surface, that causes a problem to the patient, right? So over here you can see that it's a reflection. The patient is having glare problems due to the extra amount of reflection of the light. But over here with the anti-reflective coatings, patient does not have that much glare problem as compared to the this lens. So anti-reflective coatings are very important to reduce these type of reflections, right? So which causes problem to the patient. Now what is the purpose? I have already told you that we use these type of glasses in order to reduce the amount of reflection. So here is the same thing written, that minimize the reflection by allowing more light to pass through. How they minimize the light rays, that are reflected, they minimize those rays by allowing more light to refract, right? Thus this will what happen over here, that the more amount of light will be refracted, will pass through the media, and very less or little amount of the reflections will occur, right? So this is achieved by creating a thin layer on the surface that has different refractive index than the material beneath it, and it causes the reflected light to pass through coating and into the material for better vision and other uses. So what will happen when the glare is reduced, when patient does not feel glare problems, or he is not having uncomfortable feeling, or he don't feel discomfort, so what will happen, he will have better vision ultimately due to the more refraction of the light, the more light that is passing. How we create anti-reflective coating is that it is a thin layer onto the surface of the lenses, glass lenses, that will help, that has some refractive index, right, which will help to pass the light, to pass more light into the lens, and which will minimize the amount of the reflection, right? So what are the uses of anti-reflective coatings? They are used in the eyeglasses, camera lenses. I have already told you in the spectacles, or in yeah, it's very important that in camera lenses there are anti-reflective coating that will give more better clear image, right? Computer screens, so that patient don't face difficulty or reflection problems while watching the TV or computer, and or on any other optical media which reflects in which the reflection is a problem, right? So these coatings can really improve the quality of the image, which I have already told you, or shown you over here. You can see it's a better quality vision as compared to this, right? Now, principle, on which principle the anti-reflective coatings are based? These are based on the interference principle. I have already told you over here that at any interface, right? So at any interface the light behavior occurs, like either the light decides that either the light has to refract, diffract, or reflect, right? So the principle on which the anti-reflective coatings are based is on the principle of interference, which is a phenomena that occurs when two or more waves interact with each other. Now what is happening over here, that I have already told you that there are many rays of light coming and striking onto the surface of the glass lens. So similarly over here what happens, interference is a phenomena, or it occurs when there are two or more wavelengths are moving, right? Or when they are moving, or they are interacting with one another. So what happens that when a light rays interact with each other, they can either reinforce, they can either combine the effect, or which we can also known as say, or we can say that it's constructive interface, or it can either cancel the effect, right? So if it's cancelling, it will be destruction, so it's called as destructive interface. And if it's reinforcing or it's combining the effect, that is known as the constructive interface. So on the principle of interference, the rays of the principle is based of anti-reflective coatings, and specifically on the principle of the destructive interference. We are going to discuss behavior of light first over here, that what is destructive and what is constructive. So over here you can see when these two light waves are of equal magnitude and are traveling in the same direction, it's traveling in the same direction when the two waves are adding, right? So but it has 180 apart, it's 180 apart to each other. So what is over here happening, that it will combine, and ultimately its all effect will be zero. So this says that if path difference is odd of half wavelength, it results in destructive. We will discuss what is path difference, what is wavelength, but right now you can see over here that this wave is moving like that, and this is from, it is moving from, it is originating from upward side and it is originating from downward side. So ultimately what will happen, that they will overlap, when they'll overlap their effect will be cancelled out. So that is why this is destructive. Now over here you can see these both are originating from the same direction, right? And from the same origin, they are moving from this point to upward then downward. So when these two waves of same the path difference is what will happen, they have same paths, so these will combine to each other and they will have the constructive interference, right? So now what is the theory of AR principle? So I have told you that which principle, basic principle is of interference, and particularly its destructive interference, right? So AR principles theory is that it's totally based on destructive interference, so that less amount of reflection occurs, right? The amount of reflection can be cancelled out. So whenever two waves of equal intensity or amplitude is the over here you can see this is the amplitude from this point to the height. So when the waves of two equal intensity and amplitude produced by a monochromatic source of R or superimposed, right? Monochromatic source of light means that it is coming from a single source, light is coming from a single point source, right? So when if it has equal intensity and it has equal amplitude and it is coming from a single source of light, so if they are superimposed to each other, their cancellation and neutralization is called as the destructive interference, right? Now over here, interference in AR coating and lenses. When a transparent coating has been applied to the surface of ophthalmic lens, two type of reflection can occur. So as we know that interference is when there is a when two wavelengths interact, or when two light rays interact to each other. So when the reflection can occur at the interface, right? At interface, when there is a change in the refractive index, there comes a reflection. So if we have applied a coating on a lens, what will happen, there are two type of reflection. One reflection will be between the air and the coating that we have applied a coating, and now there will be two type of reflections over there. One will be the reflection that is from the surface of the air and the coating interface, and one will be from coating and the lens interface, right? Two type of reflections are coming over here. Now according to the principles of interference, these two reflections will cancel each other into the two following conditions. Now, how the destructive interference occurs? So they are telling that the we have told that there will be two reflections. These two reflections will cancel each out other in a single in two following conditions, which are amplitude condition and path conditions. If the rule is followed and it is lying in this category, they are following the condition, that means there will be the cancellation of these both reflections, right? So over here, interference in anti-reflective coating and lenses. Now we are going to discuss these two both conditions. One is amplitude condition, that two length of wave must be of equal amplitude. What is amplitude? I'm going to add a short in the end so that you may see it very clearly, that what is interference and what is basically amplitude, wavelength and everything. But here you should know that amplitude condition is it that the two reflections should have equal amplitude, and these amplitude condition will tell you about the refractive index of the coating, right? So this amplitude is going to tell you that what is the refractive index of that coating which you have applied onto the surface of the optical media or optical lens, right? Now path condition says that it requires that reflective waves should be out of phase by 1/2 wavelength. Now what does this mean? I have told you, or I have shown you over here, that these are 90 apart, or they are path difference is opposite, or they are out of phase. They are in phase, they are emerging from the same direction. It's moving from this point to upward, it's moving from this point to downward, so it's out of phase, right? So they are saying that the both of the waves should be out of phase to each other by 1/2 wavelength. So wavelength is the complete from this point to this point, it's wavelength. So they are saying that it should be half out of phase. It means you can see over here that this is starting from over here. If I'm going to show you the you can, this wavelength is starting from here, for example. So this is a half wavelength short, right? So this is what they are saying, that they should be out of phase and have 1/2 wavelength, out of phase by 1/2 wavelength, and they will reveal the property of thickness of the coating, that the coating you have applied onto the surface is how much thick, right? So these are the two conditions on which by which the principle will happen, or destructive interference will occur, right? You can see over here they are 180 out of phase, right? This is from downward and this is from upward, so out of phase will cause the destructive interference ultimately. Now what are the types of AR coatings? There are two types. They can be single layer or they can be multi layers. So if single layer, it will deal with the majority of the reflection, but if you have applied more than one layer of the anti-reflective coating, it will turn into the multi-reflective coating, and they are good for refinement. They give you better refinement, right? If you want much better clear image, these are useful, but they are very inexpensive and are more effective, because there will be more coatings. More coatings will lead to the more minimization of the reflection, and it will give you better vision. So they are saying the difference between single and multi-layer anti-reflective coating is not as great as between uncoated and the single coated lenses. Single layer deals with majority of the reflection, and multi-layer is refinement to the further improvement. Principles and basics of both type of coating is same. So they are saying that if you compare single layer multi-layer with a lens which has no layer, so there is not much difference between single and multi-layers, right? But there is a much huge difference between single layer and a non-coated surface, right? So because single layer helps you to deal with more amount of reflection, but more refinement, if you want more refinement or more minimization of reflective surface, you will need to have the multi-layer air coatings. What are the benefits? As I have already told you, more minimization of the reflection will lead to the good vision. Now the lenses have become invisible because there are no reflections. If you have seen many patients who you can see their eyes because of the reflection, because of the reflection of the lens, right, on the lens. So you are unable to see the patient's eye. So what happens over there, that if you are using anti-reflective coatings, so their invisible lenses will lead you to see their face, right? So face and eyes properly, you can have a good eye contact with people. It will give you improve night vision because of the resolved glare problem. Glare will be reduced and eliminated completely, and you will look more attractive because your eyes are visible now, right? So this over here you can see that there are some reflections in this patient eye. So but over here it is very clear, it's more attractive, glare problems are reduced. Over here there are some patient can have glare problem during the night, or he can face difficulty during the night driving. But over here it's very difference is visible. Glare problems can be reduced. It's uncoated surface, it's coated surface. Now this is ordinary lens, it can give you less clarity, but over here anti-reflective lens have give you better quality. So over here you can see this is a image of a simple wave. So in order to understand the previous concept, I have already told you that I'll add a clip so that you may understand what is amplitude and what is wavelength and in phase and out phase. So over here you can see this is a wavelength, sorry, it's a normal wave. So from this point to the origin or the crest, we say it is an amplitude, right? This is an amplitude. And over here from the crest of one wave to the crest of another wave, it is the wavelength, right? So it is the length of the wave, or we used to say it wavelength. So what is the crest and trough if it's a wave? So the highest point is known as the crest, while the lowest point is known as the trough. And the difference between either two crests and either two troughs, right, is the wavelength, or distance between the two highest points or the lowest points, either between the two crests, or it can be either between the two troughs. So over here this was an overview of the crest and trough, as well as what is a amplitude, it is a height basically, and what is a wavelength, or the length between the wave. So it can either be distance between two crests, or it can be either distance between the two troughs. Now what is in phase and out phase? Over here you can see three waves. So I've drawn three waves over here, wave 1, wave 2 and wave 3. You can see that the wave 1 and wave 2 are originating from a same point and are moving in similar direction, right? So that the crest meets the crest, right? Crest meets the crest and trough meets the trough. So this is the in phase, right, where the crest meets the crest and the trough meets the trough. So what happens over here, when we have already told you that in constructive interface what happens when two waves combines, right, they will superimpose on each other and construct, right? So how they are going to construct, they are going to construct in a way that this crest will meet this crest and it will grow, right? It will the wavelengths will add to each other in order to make a big wave, right? So that is what in phase means. And in destructive interface I have told you that it should be out phase, right? So how much out phase? It should be out phase wave half of the wavelength, right? So how half of the wavelength? You can see the difference between wave 2 and wave 3. Over here the crest meets the trough, right? Here you can see the crest meets the trough, and here the trough meets the crest. So what happened, that this crest and trough will cancel each other out. They are going to superimpose on each other in order to cancel the wave, right? So this will give the destruction. This is how the destruction of the waves that are reflected from the coating surface and from the lens surface is done, and they help to reduce the reflection, right? Over here you can see that this wave is half of the wavelength. You can see this is the whole wavelength from this crest to this. If we see that how much difference is over here, so here you can see this is the whole wavelength, but this wave is from this point. From here only one trough is coming over here till the up crest, so this part is missing. That is why it is divided into two portions. You can see 1 and 2. So this is lambda by 2, which is the out phase, that it is starting in the opposite direction, and the trough meets the crest and trough meets the crest. In order to cancel the two waves, destructive interference occurs like this, and we achieve the destructive interference principle in the anti-reflective coating. So this was all about today's lecture. If you have any confusion, you can ask in the comment section. Thank you so much.